Very much, Antonio, for your kind presentation. I hope you can see my slides.
Yeah, everything good.
Okay, perfect. So I'm going to start, as Antonio said, changing a little bit the frequency. So we are going to move to the terahertz. And the idea is to characterize thin films and 2D materials with a tool that we call Onyx. Change, okay. We are a small company. The name is das-Nano, and it was founded in 2012. We are located in Navarre, in the north of Spain, and we are 20 people, most of them engineers or PhDs. We have three pillars, three basic technological pillars: terahertz technology, software development, and artificial intelligence based on neural networks. And we are focused on three measurement possibilities: the layer thickness, the electrical properties, and defects or hidden corrosion, for example. For this, for the photonic wall, it's clearly electrical properties, the one that is relevant, and this is the reason why we are going to focus the presentation on this product. We are a small company, as I said, but we have clients all over the world, basically in the United States, in Europe, and in Asia, mainly in China. What is terahertz? Terahertz is just a region of the electromagnetic spectrum. It's located between the microwaves and the infrared, and it has several advantages. One is because it's light, it gives us the possibility to measure in a contactless manner without touching the sample, and in a non-destructive way due to the low powers that we are using. It provides very good spatial resolution below the millimeter scale in the micrometers scale, and it gives a good penetration in the range of centimeters in most of the electric materials. We are working in time, and these are giving us the possibility to extract information in depth. And finally, and not less important, we are in the region of the electromagnetic spectrum where the light is non-ionizing, so it's harmless for humans. With all these characteristics, we are able to obtain the refractive index of the electric materials. We are able to extract the thickness of multi-layer coatings, and we are able to extract electrical parameters in 2D materials and thin films, conductance, resistance, carrier mobility, etc. And we are able to detect defects or hide corrosion. We say that we have this technology in different flavors, and the flavor is no other thing than the actuator that we are using to approach an industry. So this is why we have the possibility to see our technology in industrial robots, in collaborative robots, in tabletop robots, and in quasi-manual, depending on the problem that we are solving. And transversal to all of these flavors, we have the analytics. That is a software, basically a big data analysis and visualization platform with a high degree of interactivity. So all the data that you are collecting, it will be represented in the best possible manner that we have found it. So what is Onyx? So Onyx is a terahertz research platform for bulk, thin films, and 2D materials. We are giving you a tool, a system that is able to characterize electrical parameters of your materials. We are doing so in a contactless and non-destructive manner based on terahertz waves. We provide a full surface map and a single point of electrical properties. We do it fast, 12 centimeters square by minute per minute, and with high resolution, 50 microns. And the tool, thanks to our current customers, has been tested in many materials: graphene, many types of semiconductors, ITO, GaN, MBC, etc. The interface is very versatile. It's a clear representation of the data, easy to interpret, analyze, and export. So this is a friend for the researchers and for the companies. And why Onyx? Because what we saw is that there was the microscale world and the nanoscale world. So when you have a wafer where a sheet of graphene, for example, you have two options. You can choose to be represented this wafer by just single number, and this is what is going to be done with a DC conductivity test. You are going to associate one number of conductivity to the full wafer, or in optical examination, you are going to see just the whole wafer as a number. And we have the contrary. You can use Raman, AFM, TM, where you have really, really local information in the atomic scale. So what we saw, as I said, is that there is a gap between both possibilities. And this is where terahertz technology, our das-Nano Onyx system, could fill this gap, because we are providing a full map with a reasonable resolution. Why in your research and development lab? Because you are going to have a tool to help you to develop faster new materials. It's going to be contactless and non-destructive, so you will be able to test any sample independent on the value. Then you could follow your process because it's not going to alter it. It's plug and play, it's very easy to work with. It's accurate. It gives you full traceability of the measurement samples because it has a camera, so you will identify the region where you are measuring. And there is no need for extensive sample preparation. You just put your sample on top of our holder. And why in a production plant? Because the technology is the same. As I said at the beginning, we just changed the flavor. We just changed the actuator. And in a factory, in a production plant, you will be able to inspect 100% of your production if you are interested. So you will be able to detect really early possible errors and improve your quality as fast as possible. So in the end, you have a tool for both the research laboratory to the industrial scale, and of course, in the middle, the wafer production. This is a picture to illustrate a little bit how is our system, how is our machine, how is our Onyx desktop. You have the supply unit, that is this element that you have here, where the light is generated. The graphical user interface, where we interact with the system. And the tabletop robot that is here, it carries the sample holder, where you just need to place your sample to be measured, and the robot head that is here, where the terahertz beam goes out through this position here. And it has also a camera that is located here to see in all the time your sample and the region or the area that you want to measure. How it works? So as I said, we are illuminating the sample with a terahertz signal. The terahertz signal is interacting with your material, your 2D material that is on top of some substrate. And this interaction is getting back to the receptor that we have in the system, and we are able to extract the information we need from this terahertz signal, the signal that has been interacting with the materials. We can measure several parameters in a quantitative way: conductance, resistance, carrier density, carrier mobility, carrier scattering time, refractive index, dielectric parameters, absorb power. So many parameters related with these terahertz signals. And we can also give you qualitative measurements. So we are able to give you uniformity, homogeneity. So it's a tool that it serves you to quantify, but also to have an idea of your production process, to the evolution of your production process. As I said before, we have tested this tool with many materials in different fields. For example, in photovoltaics and in electronics. We have analyzed many types of graphene. CVD, epitaxial in inks, graphene oxide, nanoplates, carbon nanotubes, and also many type of thin films and semiconductors, ITO, GaN, PDOT, etc. So happy to test your materials with our system. And finally, I want to show you the resolution that we have. As I said at the beginning, we are able to achieve 50 micron resolution. So we are able to give really nice pictures like this one of a thin film, where you can see the difference in conductance that you have. This is very nice for a paper publication, for example, but maybe for your industrial quality control, you don't need so much resolution, and you prefer to have less measurement points and do it faster. So this is why in our system, you can choose by yourself the resolution that you need depending on the purpose that you are covering in each of the tests. We are involved in projects and scientific publications. So again, we are open to cooperate, to collaborate with you. Happy to do it. And I would like to show the last slide with an example of one of the projects that we have a couple of years ago. This is it's called GRACE project. It was for the MPIR in Euromet. And we did this project with three meteorological centers, companies and universities. And the purpose was to compare the results that we achieve with our Onyx system with the standard of the industry. And we have a CVD monolayer graphene wafer. We measure with our tool, and then we cut it in pieces, and we deliver to all our partners to be measured with other standard technologies. And we did a really nice comparison. And of one of the outcomes of this project was the good practice guide that is now available to see how we can measure these type of materials with terahertz technology. So thank you very much for your time. You can contact me in my email address. You can go to our webpage, and we are happy to say that we are trying to give light. We give new light for the industry. Thank you.